Good morning, everybody. Charlie back in Texas again. I've got another video for you today, and what we're going to be doing is fine-tuning the G-code generator spreadsheet so that when we generate the G-code and save that out, we're going to get an actual very accurate zeroing. To do this, we need to take the measurements and run a zeroing sequence and then make some adjustments, get those corrections, record that, and then make a couple of changes on the spreadsheet. But it's really not difficult to do. Sounds more complicated than it is, and I'm going to walk you through it step by step, and when I get done I think you'll be able to do this without any problems. I'm going to use this touch plate that I've got right here, and I don't know if you're going to be able to see this or not, but on the back side I've marked it with like a Sharpie to show the where the X and the Y axis are on it, so when we measure it you'll know for sure which one we're measuring. Anyway, I'm going to measure this using just a plain old tape measure, nothing fancy, no calipers involved. So I mean, if you just had an old wooden ruler from back when you're in grade school, it would still work, and still you would be able to obtain a very accurate zero. I'll be using Pixender, and I think you can probably see that over my shoulder behind me, and that's the, in my opinion anyway, that's the best one to use for this. You can use Universal G-code sender, and I'll try to take a screenshot and add this in the video to show where you'll get the numbers from, and that'll make more sense when I get into it. But anyway, enough talk, let's get to it. And what I didn't do, which I will correct, I didn't put a box for the original measurements up here, so I'm just going to write them above that line. So for the x-axis, I'm going to write down 2.125 inches. Okay, now I'm going to measure the y-axis, and that is just short of 2.5 inches, so I'm going to make it 2.5. And then the thickness of the touch plate, we'll measure that for the z-axis, and that shows to be almost 3/4. So let's go way off on that one. Let's make it 7/8 of an inch. So 0.875. So we can tell right away that when we use these numbers to generate the G-code, it's going to give us a zeroing position that's going to be nowhere near where we want it to be. But that's okay, because it gives us a starting point, and since we're using such primitive stuff like a old tape measure, the CNC machine will actually help us get the exact, get down into the thousandths of an inch for corrections. So let's move over to the spreadsheet, put some of these numbers in, and then we'll zero the bit. Okay, I've got the G-code generator spreadsheet open, as you can see, and what I'm going to do now is I'm going to put in the X, Y, and Z axis measurements that we took with the tape measure just a moment ago. So for the Z axis we put down 0.875. For the X axis we put down 2.125. And for the Y axis we put down 2.5. And then what we're going to do next, and let me zoom out just a tad, well I think maybe you can see it. We're going to select all this G-code right over here in the yellow boxes that was generated, and we're going to copy that out. We're going to select it all, right click, select copy, and then we'll go to our folder where we have the G-code stored, and I've got a file called Fine Tune that I'm going to save that in. So I'll just double click that, select all of the original code, right click, paste it, then I can just exit and save. So now we have a file saved that we can, for our first zeroing sequence, to fine tune this spreadsheet. So I'll close that, and I'll switch over to where you can view the bit, and then we'll run it and see how close it is. Okay, I have everything set up on the machine down here. Now I'm going to go over to Pixender and load a file. that test file that we just created. Okay, the file's loaded, so now I'm just going to send that to the machine and we'll let it do its thing. I'll hold the touch plate still just to make sure that it doesn't move on me. I'm using a feed rate of 2 inches per minute right here. You can go slower if you like, or you can go faster. This is about the right speed. The only part that really kind of seems to drag out is when it's coming down to touch the Z-axis. But that's okay because it goes slow enough and in small enough step sizes that it doesn't just slam into your touch plate and mess up your bit. Okay, it's finished there, so I'm going to remove the touch plate and my ground wire. And now I'm just going to send this to 000 and we'll see where it winds up. So there's X0, Y0, and Z0. Now, as I'm sure you can see here, it's quite a ways off. And you may have already experienced this yourself, which is not uncommon. And that's because computers, but the difference is in CNC machines. So what I'm going to do is, the first thing I'm going to do is I'm going to raise the bit because the tip of the bit is well below the surface of the material. So I'll set my jog units to 1/10 of an inch and raise my Z up. I'll just raise it a couple. Okay, I'm going to set my jog units for the X and Y axis to 0.01 inches. And now I'm going to start jogging to the right until I line up with the X-axis of the material. A little bit more. Actually, I think I've got it right there. Okay, so now we're going to go and move the Y-axis and get it to line up, and you're not going to be able to see that very well, but I think you probably believe me when I say I got it there. Okay, we've got the X and the Y lined up. Now we have to take a reading, and I'm going to move the camera here so you can see where I'm getting these readings from. Okay, we're back looking at the PicSender screen, and right up in this top right corner where you can see the coordinates where the bit is located right now since it's been zeroed. And this is the changes that we made to get it to the X and Y axis to line up just right. So as you can see right here for the X axis, I've got a distance of 0.13. So I'm going to write that down on that worksheet, and I'll show that to you after I get them written down. And also note that these changes are positive numbers and not negative. If they were negative, we would write them in a different column, and I'll explain that in a minute. But for now, just note that these are positive numbers because they don't have a negative mark next to them. So for the X-axis, we had a positive correction of 0.13 inches. For the Y-axis, we have a positive correction of 0.04 inches. Ignore the Z-axis for right now because we haven't actually set that yet. The only reason it's not showing what it actually is because if you remember correctly, the bit was way too low and we had to raise it up to clear the material. So now we'll switch back over to the view of the bit, and we'll get the Z-axis correction. Okay, this is the exact same position the bit was in when we left it a minute ago. And what I'm going to do now that we've already recorded our corrections for the X and Y axis, I'm going to jog the bit 1/4 of an inch into the material in both the X and Y directions. And in PicSender I can do this in one step with their X plus or X minus, X plus, Y plus button. And there it is. So this is the last time you should ever have to use a slip of paper to zero your Z axis. But to get it right, or as close as we want to get it, we have to do it this way one time. So I'm going to put the piece of paper underneath there, and I'm going to start lowering the bit, and I'm going to switch my jog units to 0.01 inches. I'm going to jog down until I trap the paper. Then I'm going to raise it up a little bit and then start jogging down at 0.001. So we'll start going down at 0.01 now until we get it trapped. Oops, down a little too far. So I'm going to bring it up until it lets go. Okay, there we go. So we're free of it. So now, so we get an even more accurate zero, I'm going to change my jog units to 0.001 inches. And I'm going to jog down until I trap it again. And there we have it. It's stuck in there, but it's not penetrating much. I can pull it out, maybe. Yeah, I can pull it out without tearing the paper, but once it's out, I cannot get it back in. So it's right down on the surface. Yep. Okay, so now we're going to go back to the computer screen view and see where we get that correction from. Okay, we're back looking at Pixender, and as you can see right here, for our z-axis we have a correction of 0.1010. So I'm going to write that down on our worksheet here. 0.1010, and that's a positive correction. Again, I'll see if I can get you to see this sheet of paper here now that I've got everything written on it. And you'll notice that the columns at the top, I corrected that. They did say all X's. Anyway, on this bottom row right here, you can see where I've put in our positive correction. So now we're going to transfer over to the G-code generator worksheet, enter these corrections, and generate some new G-code, and we will be done. So let me open that sheet up. Okay, back on the G-code generator spreadsheet, we're on the inch mode page, and you'll notice right here we still have all these original measurements that we took using the tape measure, which gave us such a horrible zeroing. So now we're going to correct that, and if you look at the bottom of the page, all the tabs, you'll see a tab that says fine tuning. Click on that. Once you get there, underneath the blue box where it says inch mode fine tuning, that's where we're going to work. If you're working with millimeters, it'll all be the same, but your measurements will come from the millimeter page and not the inch page. So right now it says current measurement for the X 2.125, which is what we measured the X-axis at. The Y is 2.5, which again, that's where we measured the Y-axis, and the Z at 0.875, which is where we measured that axis. All of those using that high-tech tape measure I have. So then we ran the G-code to zero the bit, and then we made some adjustments. And on this sheet of paper that we've got up here, we have the adjustments. So over here on the left we have negative correction and positive correction. We want to use positive correction because all those numbers that we took from Pixender were positive numbers. There were no negatives. If you had a negative correction, then you would put it in the negative column. But you do not want to have a negative and a positive both in the same column. They'll cancel each other out. Okay, so positive correction should be 0.13, and I've already got that put in here. Our negative, that's for the X-axis. For the Y-axis, our correction was 0.04, so I'll put that in 0.04. And for the Z-axis, it's 0.1010, and I think I already had that in there. So that's fine. Now then, in the yellow boxes down here it says new value. These are going to be the new measurements for our touch plate. So we're going to start with the X-axis, choose the new value, and it's probably best if you just write them down so you don't have to bounce back and forth. So I'm going to do that, and I'll make a column for writing those down on this worksheet before I upload it. But for the X-axis, our new value is 1.995. For the Y-axis, it's 2.46, and for the Z, it's 0.7740. So So once we have these new values, and like I say, you don't want to right click and copy, because those cells contain formulas and you'll be copying the formula and you won't get the right result. So once you've just written those numbers down, go back to your inch mode page, and we'll start here with the z-axis. The new value for the z-axis we wrote down was 0.7740. The x-axis was 1.995, and the y-axis was 2.46. Okay, once we've entered all those, you probably didn't see it happen, but these yellow boxes, the G-code in these boxes actually changed because it updates on the fly. So every time you change one of these change automatically. So what we're going to do now is we're going to, just as we did before, we're going to right click, drag, or left click, drag to the bottom, right click, choose copy, go to our File Explorer here, go to the folder where we have our G-code saved. There's our fine-tune folder that we just did, our file. So we'll select all that, right click, paste it, and then we can just click close, and we want to save the changes. Okay, so now we have a brand new G-code file, and also you want to go up here in your spreadsheet and save it. So just go over and click save. And the reason you want to save this is because these are the new measurements that are going to affect all of your bits. So after this works out, and we'll test it to make sure we zero correctly, and if it works out correctly, which I'm sure it will, then you'll want to recreate any G-code files that you already have since you've made an adjustment to the touch plate, and then you'll be more accurate with every bit that you have. But you only have to do this one time unless you make changes to your machine that would affect travel. So anyway, save that. We got our G-code file saved. So I'm going to go back to PicSender, and I'm going to click on load, and here's our fine-tune file that we just made. I'm going to open that, and now I'm going to transfer back down to the bit, and I'll reset that. We'll run that file and see how close we get. Okay, I've got the touch plate wired back up, the bit's in position. I've loaded the file that we just saved after we made the fine-tuning corrections, and I'm going to go ahead and send that file now, and we'll zero this bit out, send it back to zero, and see just how close we actually got. Okay, let's move everything out of the way, and in PicSender I'm going to click on go to 0 for the X, go to 0 for the Y, and go to 0 for the Z. And let me zoom in real close here for you, and I think you'll agree that we got a really good zero this time. Yep, that's right on the money. And that is how you fine-tune your spreadsheet to get a perfect zero, even though you don't have calipers or anything else. And this will affect every bit that you have now because you changed the settings in the spreadsheet. So be sure you recreate any files that you've already done for different bit sizes. And that's it.